Okay, so here's another example. We have z is equal to x plus some function of u, and u is equal to x times y, and they're asking us to show that x times the derivative of z with respect to x minus y times the derivative of z with respect to y turns out to equal x. So we're just showing that if this is the case, then z satisfies a particular partial differential equation here. Now, when we look at it, we're taking derivatives with respect to x and with respect to y. That must mean that x and y are independent. Okay, so if x and y are independent, then that would mean that u has to be dependent, right? Okay, and then z depends on what x and u are, so z is also dependent. So let's find we need to calculate z sub x and z sub y, and then substitute them into this equation and see if it simplifies down to be x. That's our plan here. So let's calculate the derivative of z with respect to x. So we take the derivative of this with z with respect to x would be equal to the derivative of x with respect to x, which is 1, plus we have u inside a function, so we get the derivative of the outside evaluated to the inside times the derivative of u with respect to x. Okay, we get something similar if we take the derivative of z with respect to y. Since x and y are independent, the derivative of x with respect to y is 0, and the derivative of this with respect to y would be the derivative of the outside function evaluated at the inside function times the derivative of the inside function with respect to y. So what we've got to do is figure out what's the relationship between du dx and du dy, and we can get that from our constraint here. So we take the derivative of both sides with respect to x, we get du dx is equal to, if we're taking the derivative with respect to x and y is independent, then y is just a constant, so we just get this constant times the derivative of x with respect to x, which is 1. Also, we can see from this that du dy is going to be equal to x. So that means that let's see, dz dx from up here is 1 plus f prime of u times du dx, which is y, and dz dy from here is f prime of u times du dy, which is x. So they're asking us to take x times dz dx, that would be x times this, and x times that, and subtract y times this, so minus yx. If we add these up, we get x z sub x, right, minus y z sub y, just convert it to that easier notation, quicker notation, and then we have x plus xy times f prime of u minus x times y times f prime of u, so all we have is x. So we verified that that is true.